Number 20, identify the atoms that are oxidized and reduced, the change in the oxidation state for each of them, and then find the oxidizing and the reducing agents in each of the following equations. And then we have letter F out of the bunch. So we need to figure out of this whole equation, which atom, or basically which element, is going to be oxidized or reduced. Now, since we're talking about oxidizing and reducing, we're talking about redox reactions. So this whole reaction here is classified as a redox reaction. And a redox reaction always has changes in oxidation states, aka the charges. And there's always going to be a change in the charges of the individual atoms. There's not going to be a change in all of them, but some of them will change from reactant to product. So that's the whole basis here. We have to find out what the changes in the atoms that go from the reactant to the product, which means that technically we should find the oxidation state for every single atom from left to right. So let's go from left to right, and let's just start by doing copper. Let's find out the oxidation state of copper. I'll put it over here. Copper, it just was a solid, right? There's 3 of them, as said by this coefficient, but copper is just by itself. The rule is that if you see an element by itself and there's no charge in the upper right-hand corner, that element has a 0 oxidation state. It is a neutral compound. So that one was easy enough. This one started off as a charge of 0. But now since I have a compound, I have nitric acid, HNO3, I have to find out the charges of H, N, and O. So maybe I will do that over here. So I have HNO3, and we've done tons of problems in which we found out oxidation states, right? So let's see, remember that if we have 3 atoms, or 3 different elements in one compound, the trick is that we're probably going to know the oxidation state for the front, we're probably going to know the oxidation state for the last element, but we need to find out the oxidation state for the middle one. Use your trends, the trend that I provided here, to just tell me, or just write down, what the oxidation state for hydrogen and oxygen are. Well, hydrogen is in group 1, and generally that wants to be a +1 charge, so +1. Oxygen is over here, group 16 or 6A, and oxygen wants to be a -2 charge. We just need to find out what the nitrogen is. So I label it as X. I don't know what it is. Now, on our chart, it says that nitrogen wants to be a -3, but when you have 3 elements in a compound, chances are the middle one isn't going to follow the trend. Now, just know that, when we set up our equation, it has to equal something. Well, it's always going to equal, and I'll maybe put it over here, our equation is going to equal the total charge. The total charge is always in the upper right-hand corner, right? But if I looked at HNO3, they didn't tell me a charge over here, right? So that means that it's also neutral, just like copper was neutral. So it's got to equal 0. Now, all you have to do is just multiply your oxidation states, so I'll color code this, right, with how many of each atom you have. So it's HNO3. I have 1 H, I have 1 nitrogen, and I have 3 oxygens. So multiply the +1, that's the oxidation state for hydrogen, and times it by how many hydrogens you have, 1. So +1 times 1 is just 1. X, which was nitrogen's oxidation state, times 1 is just 1x or x. So I'll say +x. And then -2 times 3. -2 times 3 is a -6. So there's my formula. 1 + x minus 6 all equals 0. So just clean this up, right? 1 minus 6 is a -5. So I could do it that way. And then if I just plus 5 on both sides, I get X being a plus 5. And that's the oxidation state for the nitrogen. You see how it didn't follow the trend? So now I'm just going to write those charges. I knew that H was a +1. I knew that oxygen was a -2. But now I just solved for the nitrogen. That was a +5. Okay. Let's go to the next one. CuNO3, 2. Okay, there's 3 elements here, but let's just try to do it a different method. I'm going to put it over here. So I have CuNO3, 2. In this case, I'm going to use the crisscross method to get rid of the positive charge from the negative charge. I notice that I have NO3, which is nitrate, right? And that's one of our polyatomics. But use your coefficients use your subscripts to crisscross back up. I have 1 copper and 2 nitrates. This 1 crisscrosses up telling me that the nitrate was a -1. And this 2 crisscrossed up telling me that the copper was a +2. So I have I have Cu being a 2+ charge and an NO3 being a -1. And from memorizing the polyatomics, I know that this is correct, which means that this copper charge has to be correct. So the copper is a +2. Now, I have to solve for the individual atoms here. Now, there's 2 things that you could do, right? You could do what we did before by setting up an equation. Generally, the oxygen is going to be the -2 charge, right? And then just solve for X for the nitrogen. However, I want you to note that this was an NO3, right? Nitric acid came from nitrate. And this is a nitrate, right? So the nitrate didn't break up, it stayed the same. So the oxidation states that are in the nitrogen and the oxygen of nitrate will always stay the same. So that means that if this was a +5 for the nitrogen, this nitrogen also has to be a +5. And then the oxygen was a -2. But just if you want to do the math on this one, go right ahead. There's so many different ways of doing these problems, but just as long as you get the right answer. Okay, moving on. I got to find the oxidation state for N and O in NO. So maybe I'll put that one over here. We have N and O. I have 1 of each. I have 1 nitrogen and I have 1 oxygen. I'll crisscross these to see what the charges are. So this one crisscrosses up to oxygen, saying that it was a -1. And this one crisscrosses back up, telling me that nitrogen was a +1. So as of right now, I have N being a +1 and an O being a -2. Oh, no. I went too fast, guys, because I was going to say, is this the trend? No, no, no. Oxygen wants to be a -2. So what do we have to do? We have to multiply this by 2, but you got to be fair. I'm going to multiply this by 2 as well. So now that makes oxygen a -2 and the nitrogen a +2. And then last but not least, let's just do H2O real quick. I could maybe do it down on the bottom here, H2O. You could do the crisscross method for this, right? There was 2 hydrogens and 1 oxygen. So the 2 crisscrosses back up, telling me that the oxygen was a -2. This 1 crisscrosses up, telling me that the H was a +1. So I have H being a +1 and oxygen being a -2. And those are the trends on the periodic table. So that's all cool. So I'll just write them down. H was a +1 and O was a 2-. Okay. Now we have to take note of the changes. Let's go. We'll start from left to right. I see that copper started off with a 0 charge, and maybe I'll bring this a little bit down. Copper started off with a 0 charge, and it went to copper being a 2+ charge. That's a change. I only care about the ones that change. So I'll put it down over here. Copper started off as being a 0 charge, and it wound up being a +2. Okay, we go to the next one. Let's see, H. Our H's on the reactant side was a +1, and if I scan this way, whoop, I'm crossing over here, but my H was a +1. No, that didn't really change, so I don't care about it. I move to the next one. The nitrogen here was a +5. It stayed a +5 here, right, from reactant to product, so I don't care about that. However, I have another hydrogen, so I have to make that relationship. Let's see, the nitrogen was a +5, and it turned into a +2. That's a change, so I have to write it down. Nitrogen started off as a +5 charge, and it wound up being a +2. Okay. And then let's just finish up with oxygen. Let's just see if there was any changes. Oxygen was a -2. Oxygen was a -2. Oxygen was a -2. And oxygen was a -2. Oxygen's charge didn't change no matter what it did. So I could just get rid of it. Now we have our two changers here. Copper was the only atom that changed, and nitrogen was the only atom that changed. But now the question is, which atom, copper or nitrogen, was oxidized and which one was reduced? Look down here, guys. Remember the mnemonic. Leo, the lion, says grr. L-E-O-G-E-R. Leo, the lion, says grr. LEO is a loss of electrons, and that's oxidation. Remember, electrons are negative. So if you're losing negatives, you're going to look as if you're gaining positives or becoming more positive. If you're gaining electrons, which is reduction, right? Remember, electrons are negative. If you gain the negative guys, you're going to become more negative. So from reactant to product, let's look. The copper went from a 0 to a +2. Did it become more positive or did it become more negative? It became more positive, right? So that means that it had to have undergone oxidation. So the copper was the one that was oxidized. So if you know which one was oxidized, and in this case it was the Cu, I kind of know which one is the reduction one, right? It's got to be the opposite. But let's just make sure that makes sense. Nitrogen went from a +5 to a +2. Did it become more positive or it become more negative? Yeah, it became more negative, right? From a 5 to a 2, you lost some numbers. So nitrogen had to be reduced. So that's the answer to that question. The change in the oxidation states for each, we just did that, right? Copper went from a 0 to a +2. It was becoming oxidized. And how many electrons did it actually lose? You think of it in terms of a number line. If I go from a 0 to a 2, I had to go over 2 bunny hops. So that's how many electrons you lost, right? So in this case, you lost 2 electrons, and I'll put like E negative. Nitrogen, each nitrogen, let's see, went from a 5 down to a 2. How many bunny hops? 1, 2, 3, right? Or if you go to 2 to 5, it's the same thing. It's 3 bunny hops. So in this case, you gained 3 electrons. So that takes care of the change in the oxidation states. Now we just have to find out which one was the oxidizing agent and which one was the reducing agent. Just make sure, guys, the atoms that are undergoing oxidation is the compound that is the reducing agent. They go hand in hand. Reducing agent just means that you are the compound or the molecule, the agent, that helps the other molecule get reduced, which means that you are oxidized. So it's actually talking about the other compound. So oxidation is the reducing agent. Reduction is the oxidizing agent. So this should be oxidizing. Typo. But anyway, yeah, you guys get it. So let's see. It stems from these atoms, copper and nitrogen. Copper was here, right? And if copper was the one that was being oxidized, that means its whole molecule or the whole compound was the reducing agent. But I mean, literally, it's just copper, right? So it's the same answer in this case. Chances are, though, it's not going to be the same answer. So copper, solid, the whole molecule, you don't have to put solid, is the reducing agent. And then on the flip side, the nitrogen was the one that got reduced. So the nitrogen was here. And I just want to make a quick note, because I think I didn't say this in this video, that when you're talking about your agents, your oxidizing agent and your reducing agent can only be your reactants. So by default, it can't be these compounds. So now you're down to only two. One is going to be the oxidizing one, the other one's going to be the reducing one. So if nitrogen was the one that was reduced, the whole compound, which is the HNO3, was the oxidizing agent. So HNO3, aqueous, you don't have to put that, was the oxidizing agent. And there you go. There's all the answers in like a nutshell. So copper, the molecule, was the reducing agent. However, the same thing, copper was the one that was being oxidized. HNO3 was the oxidizing agent, which meant that the nitrogen was being reduced. And then here are your changes in the oxidation states. Guys, what do you think? I hope this helped. Let me know in the comments if it did. Love talking to you guys, and I hope you guys are doing well and that you're doing awesome in your classes. Yeah, if you want, click that subscribe button. That would help us out. But if not, that's okay. I'll see you guys in the next lesson. Have a great day.